we go. So we talked about acids and bases. So at this point, you should understand what? Arrhenius definition of an acid, Bronsted-Lowry definition of an acid or base, right? That if I were to give you a blank sheet of paper, can you legitimately recreate that chart without having to look at your notes? If you can't, write yourself right now. I got to study. I'm not studying, right? Right? Do you like 90s? I'm sure you do, right? If you are, that's a 98th percent student, okay? Right? If you don't do that, don't get upset if you're doing poorly in my class, right? All right, what else? We talked about physical characteristics and chemical characteristics, right? What are physical characteristics? Well, we talked about what it feels like, what it tastes like. You shouldn't taste anything in the lab, but what it tastes like and all that stuff. Chemical characteristics are what? Yes, it could be like caustic, right? Burning and all that, but really more for us at this point, you being mature chemistry students, chemical characteristics of acid and base would be more related to how things happen at a equation level in a reaction, right? Like, for example, an H plus, whether you call it as an Arrhenius hydrogen ion or a Bronsted-Lowry proton, you know, seeing it pop off and on, that's a chemical characteristics. What else? Understanding how to identify an acid as a chemical as an acid is also important. We also covered a concept of polyprotic acids, right? So that's something else that you should be aware of, right? One other thing that I want to talk about when we talk about polyprotic acid is this, right? One of the things is, here, let me go to pen. All right. We know for sure that this is what? It's polyprotic, right? Anybody know what specific polyprotic acid is called? How many? What kind of protic? It's what protic? What do you think? How many wheels? Well, I understand that, but if a vehicle has two wheels, what is it called? Yeah, dicycle, right? So what kind of polyprotic acid would this be? Yes, sir. Diprotic. This is a diprotic, right? Diprotic is part of polyprotic, right? There's also triprotic, right? Is there a tetraprotic? And the answer is no, because that's too many hydrogens, right? And if you think about it, right, this is not part of Regents Chem, definitely part of regular high school chemistry, right? Which is this. Do you think molecules really like losing atoms? No, they don't, right? They don't, you know, but there are happier states and unhappier states, right? You remember we talked about how hydroxide is an OH minus? It could also be H2O by addition of proton. And we said it's probably happier being H2O. That's why there's more water in the world, right? Likewise, H3O plus, which was hydronium. And we said, how happy is hydronium? Probably not, right? Because H3O plus is water with an extra H plus, right? So we said, most likely, it's probably not going to like being that. That's why we said, when you have a concentration of H3O plus, that's the same as writing the concentration of H plus. Remember all that, right? Now, what does that mean? As much as maybe sometimes an acid might like getting its proton ripped off, because in a case of HCl, it's happier as a Cl minus. That's why this is a strong acid, because whenever you have an HCl, it likes to flick off that proton, right? And be like this. However, as you keep popping them off, what happens? You should understand this now because of redox. But, ready? If Adita is an acid, she's neutral right now, right? But definition of an acid is what? She's going to donate H plus, right? So if she pops off an H plus, is she still neutral? No. What is she now? Yeah, she's negative. She's an anion, right? What if she was polyprotic? Okay? Which means that on her left hand, she's got a proton. On her right hand, she's got a proton, right? So she's got two H pluses on either hand. She's like sulfuric, H2SO4, right? When she loses that first proton, Justin just said she's going to be a little bit more negative, right? Now, she's polyprotic. She's diprotic, which means that she can lose another proton. However, ready? Adita, I'm going to try to pull away an H plus. What's the charge of an H plus? Yeah, from somebody that's already negative. Is that going to be as easy as before? What do opposite charges do? Yeah, attract. So in polyprotic acids, the more proton you keep popping off, the more negative the remaining thing becomes, which means it's going to hold on to its proton a little bit harder, right? So I know Regents talks about first ionization energy, right? First ionization energy is to ionize once, right? But the second and third subsequent, it gets harder and harder to do that. So that's why there's no such a thing as a tetraprotic acid, because by the time you rip 3 protons off, you're a -3. There's no way in God's green earth that you're going to rip another H plus off, even if it has one. All right. Now that goes on to another thing that we understand, which is acetic acid. Let's take a look at acetic acid real quickly. Acetic acid, right, is something that you should know because it happens to show up on regions all the time. But acetic acid is HC2H3O2, right? And this is also known as ethanoic acid in your reference table, right? So acetate ion on table E is C2H3O2 minus, and acetic acid is HC2H3O2, or it's also known as ethanoic acid. Well, what do we notice about this guy, guys? What do we notice about this? How many protons do you see here? Raise your hand. Raise your hand. How many protons? How many hydrogens do you see? Yes. There's 4 hydrogens. So you're thinking, well, Mr. Kim, does that make this tetraprotic or polyprotic? And the answer is no. Why? Because what this does undergo is this. It will do this. Right? However, in order for this to be polyprotic, it would mean you have to take another proton off, right? But if you took it off, then what would you end up with? You would end up with C2H2O2 minus 2. Right? Right? So you would end up with, right? If polyprotic, then it would mean this would do one of these, right? Problem is, have you ever seen anything like that? If you go to the table of polyprotic, this is why I said back when we covered table E, it's not a bad idea for those of you who want 90 percentile on regions to memorize your polyatomic ions. It's not a bad idea because think about it. If you come across a question like this, you don't have the time to go to table E and see if this, like you're going to need 10 hours to take this test. But if you memorize the chart, you would immediately know that, right? Does not exist. So therefore, this whole thing cannot happen, which means most likely HC2H3O2 is not polyprotic, but monoprotic. Okay? Why? Because this H cannot be removed. Now, some of those who went back and looked at notes from like October would realize Mr. Kim said polyprotic polyatomic ions are bunch of atoms that have bonded covalently that as a group acts like a single ion. You sure you said that? Yes, because that's literally what I say if you stop me on the street, right? What does that mean? It's a covalently bonded guys that as a group have a charge. That's why it acts ionic, right? So that means that the C2H3O2, they are all connected using covalent bonds, and covalent bonds don't fall apart in water, which means that they cannot turn into ions. Done. All right. So that's where that comes into play. So it's not that chemistry is difficult. Chemistry is difficult only because in order for you to be good at chemistry, you need to not forget stuff, right? The person who's going to be the best at chemistry is the one who's going to be able to retain all your previous knowledge and still be able to, you know, think about it, right? All right. So that's a big difference between me and somebody else, right? All right, here we go. Neutralization. So we said we know what neutralization is. Neutralization is when acid neutralize base. But what is it? Or base neutralize acids. Together, what do? Right? I've briefly touched this, very, very briefly, when we cover types of chemical reactions. But now that you understand how to identify an acid and a base, you understand that acid and a base will always form salt and water. All right. Acid and base always form salt and water. But be careful. When they say salt, it's a chemical definition of salt. It's not literally sodium chloride, right? That's what everybody else in the world thinks about when you hear the word salt. But for us, salt means anything ionic. So salt could mean, right, NaCl, KCl, Na2SO4, that's a salt, right? And on and on. These are all salts. All right. So let's look at that. Being said, saying that it's not literally NaCl, let's look at an example of an acid-base interaction where you get a salt and water. Here we go. So let's look at one. So I'm going to pick a strong acid. HCl is one of the strong guys, right? It's one of the three major strong ones, right? You got hydrochloric, you got sulfuric, and nitric. Those are the three strong acids. There are others, but those are the three major strong ones. Strong bases, right? Be careful, right? Most bases on the base chart are actually weak. Sodium hydroxide is a super strong base. So sodium hydroxide and hydrochloric are two strong acid and bases. So what? So let's combine the two, right? To combine the two, what do? You put them together like that, right? So you got HCl and NaOH coming together. And then what happens? Well, what do we know? Oh, announcements.
Oh, good morning, Artley. Today.
Good morning. Let's pause this.
A day. Please stand for the pledge. I pledge allegiance to the flag of the United States.
I will open the door back up, right? Yeah, so hopefully the recording pause actually worked because I tried to do this with AP at home, and then what happened? My dog started barking, so I paused it and I was like, "Ooh, who's a good dog?" Right, you know that, and it all got recorded, right? Anyway, so I had to download it. I was like, "Ooh," it's like you're a good doggy, right? I'm like doing that, and I go back and I upload to YouTube, and it's actually the AP questions I went over, and I put it up there, like for anyone. And then I'm like, why is this video so long? It was like for 10 minutes, me playing with my dogs at my office, right? And then I was like, so I had to get rid of it. So anyway, hopefully that stuck because I paused it. But it said it got paused last time too. All right, so let's look at this, right? Couple of things to look at here. What do you notice, guys? Well, this is what? Yeah, I mean, it says here, but even if I didn't say that, you recognize this as an acid, right? Hopefully you won't have to go to table K. Table K is a backup in case you don't know, but you should know. Oh, wait, I see an H in the front, all right? Not to mention, guys, remember what I said? hydrochloric, sulfuric, and nitric. You should memorize that as being three major strong acids. Acetic is an example of a weak acid. Honestly, I almost feel like in Regents, they will not use any other examples other than those. All right. Even though there are others. All right, so that's an acid. What do acids do? What is going to happen to this guy? What's going to happen? Yes, sir. Pop off the what? Yeah, it's going to pop off the H as an H plus, right? What about this? What kind of base is this? Is this an Arrhenius definition or a Bronsted definition? Yes, sir. Right. Why? What did you see, Sebastian? Hydroxide. Good. So what do we know? It's going to also pop apart. And when that happened, what happened? The hydrogen here decided to pair up with the OH to give you this, right? Do you see that? Yes? And then what happened? The sodium decided to pair with the Cl and do that. In fact, what did they do? They swapped partners. Does this look like something you know? Double replacement. So neutralization is a specific example of a double replacement reaction. It just happens so it's a double replacement where one of the products is always going to be water. All right? So remember that. If they say, hey, which of the following is a double replacement? And you see four choices, and if you see acid base turn into water and salt, you're done. That's neutralization, which also happens to be double replacement. Remember what I said? Take tests easier, not harder. All right, so let's keep going, right? So cool, all right? It's kind of nice. Some of you guys wrote that down, like, oh, you know, you put, oh, snap, this is a double replacement. Do you guys still say that? Do you say, oh, snap? No? Are you guys thinking, like, seriously, like, what the heck are you using? You don't say snap? Back in my days, we used to say, oh, snap, or like, cool, or like rad, gnarl. No, okay. All right, so here we go. So we got our salt and water, right? So that's our salt. It just happens. So in this case, our salt is literally table salt. So what does that mean? Hey, if I put HCl in a cup, gave it to Tiernan, what would happen if he took a chug? He'd be like, oh, wow, that's like the sourest. And then he would pass out. And then we're like, hey, I think he's dead. Where's his jaw? It's melted, right? That's HCl. What about NaOH? If I gave you a cup of NaOH and let's say, I don't know, Dennis drank it, he would be like, oh, that's so bitter. And then he would be dead, right? And then we'd be like, hey, where'd all his hair go, right? But what happens if you take a perfect ratio of sodium hydroxide and HCl, mix it together, and have Brian drink it? What would he say? What would you say? If you take a perfect ratio of HCl and NaOH, both of these will kill you, by the way, and then mix it so it's a 1-to-1 perfect ratio and have Brian drink it, what would his reaction be? Yes, sir. Yeah, he'll be like, it's salty water. Is that crazy? Isn't that, to me, that's why chemistry is pretty wild, right? You can take something that'll dissolve your tongue and kill you. You can have something that'll dissolve all the hair off of your body and also kill you, right? And if you mix the two perfectly, what do you end up with? Salt and water, right? Now, you're thinking, Mr. Kim, if that's the case, wouldn't that be a kick-ass demo? What do you mean? You know, literally just give Tiernan a cup of HCl, Dennis a cup of NaOH, and after they're dead, you mix it, and then what happens, right? I mean, or you say HCl and NaOH, mix the two, and then say, hey, Tiernan, drink it. And he goes, oh, man, that's salty, right? Why would we never do that demo in this class? Because why? In order to figure this out, you need to figure out exactly 1-to-1 molar ratio, right? You guys know how to do that? How do you get 1 mole of NaOH? It's 23 grams per mole and 17 grams per mole. That's 40, right? So it's NaOH is 40 grams per mole, which means that if you have 40 grams, you have 1 mole, right? HCl, chlorine is what? 35.45 grams per mole. Hydrogen is 1 or 1.008 grams per mole. So that makes it 36.45 grams per mole, right? So if I have 36.45, let's write it down. So if I put, right, 35.65 grams, and then we have 40, right, 0.0 grams, these both are going to be 1-to-1 mole ratio. Okay? Great. If I mix that, we should get all this and none of this left over, right? What happens though if I accidentally put in 41 grams of sodium hydroxide? Then what happens? Yeah, we make this, but there's still NaOH floating around. That's dangerous. What happens if I accidentally go, whoops, and then put in 37 grams of HCl? Now you got salt water with free floating HCl. Do you want to drink that stuff? No. This is the reason why. If you watch, do anybody watch Breaking Bad still? Anyone? Yeah. So if you watch Breaking Bad, like, you know how they said, oh, Mr. White, he makes that, the 99% purity, right? That's what purity means, right? Walter White, the chem teacher in Breaking Bad, knew how to do this so that when you create it, it's almost 99.9% this and only 0.1% impurity, right? That's why he made the better drugs in Breaking Bad, right? That's the idea that, let's say, if in a alternate universe, if one of you decide to be like Jesse and make street drug, right? You can kill people. Whereas, let's say, if somebody like me, I decided to help you out, what would happen? We would create the purest, right? So that's the idea behind Breaking Bad. That's the idea behind chemistry, right? And that's how we don't taste anything in lab, because even though I put in 40 grams and 35.65, it may not be perfect, at which point what happens. Because remember, we have sources of error, right? All right, let's go. This is called neutralization reaction. All right, you already know this. This is from the previous slide, right? So you don't have to rewrite that, right? Remember anionic. It's just, all right, so let's keep going. Let's keep going, right? Let's look at another one like this. Can you combine this? Why don't you combine this one and see if you can come up with a chemical reaction for neutralization. Now remember, in order for you to do this, you got to put the two together, perform the double replacement, and then on top of that, this one has got a little bit extra I threw in there for you, right? The easiest is what? To write the acid and the base down, carry it down, right? And then what do you have to do? Apply your knowledge of acid and base to take it apart into ions and then perform your double replacement. So if you did that, you would get up with something like this, right? Why? Because, ready? I'm going to say it. The acid is monoprotic versus while the base is diprotic, right? Two hydroxides. Therefore, you're going to need twice as many monoprotic acid to react with the diprotic base, right? Or more simply put, you got to balance the equation, right? Right, buddy? You got to balance that equation, right? And just like before, we got acid and base and salt and water. Except this time, the salt is who? What is that called? You know how to name that? Name that tune. Oh, I only know the calcium part, Mr. Kim. What? Calcium nitrate. All right. So the salt is calcium nitrate, right? And water. And so what do we notice? We created twice as much water, right? As before. Mole per mole. Doesn't mean we literally create twice as much water, but for 1 mole of reaction, you'd be creating twice as much number of moles of water. Okay. That's it. All right. You want to try some? Ready? Here we go. You ready? Next slide. Try your own. Ready, steady, go. Try these. Oh, these are easy, man. No, these are all monoprotic. Mr. Kim. Way to challenge the kids. I'm sorry. I'll give you 30 seconds. Should take no time. All right. That's what I'm talking about, man. It should not take you long, right? It should not take you long to write a chemical equation, write a double replacement, and then balance it, right? Even if it needs to be, whether it needs to be balanced or not. I'm gonna give you another one, man, because these are too easy. Boom. How about this? Yeah, how about that? There you go, buddy. Try that one for size. Yes. The dot.
Yeah.
Ah. There you go. Yeah, people on the videos are like, what dot is she talking about? Guys, Luella's seeing dots. No, it's not on the video, that's why. All right, you guys ready? Let's look at the first one, right? So what I'm going to do is I'm going to dissociate it, right? Which means I know that the acid is going to take off the hydrogen here, and you're going to end up attaching that. So I know that you're going to end up with water, right? Definitely, right? Not only that, I understand that it's a 1-to-1, right? Because for now, right? And then what else? You know that the potassium and nitrate are going to pair up together. So you got a potassium and, hello. You got, all right. Ow. All right. Potassium and, oh God, potassium. Hello. What in the actual, what is going on? I just wrote KKK. Mr. Kim, what? Oh my. Guys, we have a problem. Why is it searching? Why is it? This thing is racist. My computer's been possessed by a racist software because it wants to write KKK. All right, so let's try this again. Slideshow from current slide, and then Zoom probably jumped up. Oh, did I not share the screen? That'd be really funny, wouldn't it be, right? All right, well, let's keep going. All right, I'm gonna record next period's class just in case. I have a feeling I wasn't even recording the screen, which means you just saw like the screen and I was doing nothing, right? And the video's off, so that's literally like black screen for nothing. All right, let's try some of these, right? So, hello. Please work. K. Oh, geez. How about that? Will that? Yay. K. It's bloody red. All right, so we know it's K and NO3, right? So what do we know? We know that K is what? Group 1, which is +1. NO3 is -1. Crisscross drop charges, and we know it's KNO3, right? Whoa, remember that from a long time ago? We got to remember. Now, once we wrote that, look, we got to look at the balancing, and it is balanced. This thing is good to go. Let's go to the next one. Let's go to the next one. Once again, you know that the hydrogen, oh no, there's no hydroxide because what kind of base is this? It's a what? What kind of base is this? Yes, sir. Bronsted. Why are you so unsure, right? All right, so here we go. We know that this one is going to what? Take off the H plus, right? And then when it goes here, what do you end up with? NH what? Kids? Right. Is it NH4? Did we just tack on H? We did. Hello? Does that give us this? You're telling me the charge is fine? Dude, you just came out of the rear end of redox class, man. You're telling me you're okay with this? What's the total charge on this side? Class? Total charge. How many charges do you see here? Do you see a charge? Yes or no? So that's 0. What's a charge here? Do you see a charge? Do you see a charge? No. So therefore, what is it? All right. What do you see a charge? So what's the total charge on this side? +1, 0. Are you okay with it? No. Remember? So what is ammonium? Yeah, don't forget the plus, man. If you write NH4, if they say in your answer booklet, right, write the formula of the missing product, and if you put NH4, it is wrong. NH4 is not NH4 plus. NH4 is just stupid. If you write NH4 for ammonium, you're telling them, sir or ma'am, whoever's grading this, I have no idea what I'm doing. Please mark me wrong and, grade the rest of this with whatever, right? Everybody okay? Don't forget your charges, dude, right? Right now, I should not be telling you to ignore charges. You should not be ignoring charges. You see a charge, don't see a charge, do not drop charges thinking it's the same, right? I already had this talk with you. Na is different from Na plus, right? Can you eat Na? No. What would happen if you try to eat a piece of sodium? Your jaw would blow up, right? With a loud bang. What would happen? Can you eat Na plus? Sure you do. What is it? It's part of what? Salt, right? So you would never say Na plus is same as Na. So you would never say NH4. You say that, you are wrong, right? NH4 is wrong. Write that. And then say why it's wrong. Because don't forget charges, all right? I've been telling you this, and some of you are not. Look, you can call me out and like, oh, you know what? I think Mr. Kim is lying. I think he's making a big deal out of nothing. Yeah, maybe I am. But do you want to find out on regions that you failed it because you got all the answers right, but you got it all wrong because you left out charges, right? Let's not do that, all right? What's the other thing you're left with? You're left with Cl minus, right? So that would have been a little bit more difficult. Not really. All right, let's move on. What about this one? You know that the H plus comes off, leaving behind. Oh no, what does it leave behind? Well, dude, you remember what I said? It's not a bad idea to memorize polyatomic ions, but if you didn't, you would go to the table and look it up. So what do you end up with? You would end up with that, which means you again end up with NH4 plus, but then you would end up with what? SO4 2 minus. However, what do we know about this? We're unbalanced, right? How are we unbalanced? Well, how many H's come off here? 2 of them come off, which means they're going to need what? 1 ammonia or 2 ammonias? You remember? It's reacting with this to turn into that. So, and do you see how there's 2 coming off right here? So how many ammonias do you think we need? We got 2 here. How many do we need here? Hello, are you saying victory or 2? Luella's saying victory, 2 for victory, and she's right, all right? So, and then in the end, what happens? You'd also end up making 2 ammonias, right? That was weird. Pen did something funky, right? There we go. And that is the correct balanced neutralization equation. They can ask you to write the equation. They can say, hey, finish the equation in your answer booklet, and they can give you the part that's written in green, right? And you have to balance. Be prepared. All right, let's keep going. Any questions, comments, concerns? Don't forget to hit the like button. All right, let's keep going. Polyperiodic. We talked about polyperiodic, right? So I'm just going to skip through all this because we all know this. Yes? 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 All right, so let's go to pH calculations. This is fun stuff. All right, what is pH? Raise your hand if you've heard of pH. Cool. Raise your hand if you know what it means. What is it? If somebody says, hey, what is pH? If you're walking home and some taxi cab pulls up, goes, excuse me, sir, or miss, right? I'm in a game show called Cash Cab, right? You're my lifeline. Can you help me with this question? And I'm like, sure. He goes, what is pH? What do you say? Have you used it in bio? Sure you did, right? What do you say, sir?
Acidic substances.
Right. So how acidic something is, or how basic, right? Or neutral, right? Some of you had some idea, right, about neutrality and acidic basic. But how many of you in biology class raise your hand and ask Miss Joe, Doc, or whoever you had, what is pH? I'm like, what do you mean? I mean, why is it P and an H? And why is it a weird letter? Anybody ask that? I did when I was in high school. Did my bio teacher know how to answer it? Yes. That's why freshman year, bio, and I was like, wow, I have a lot of respect for her, right? Anyway, what is it called? Nobody seems to know. I ask every year, 18 years teaching high school. By the time they come from bio, and then like, how many people know what pH is? Oh, of course I know what it is, Miss Kim. It's acidic or basic. I was like, so why is it pH? They're like, you mean none of you asked why it's pH, right? Guys, be curious. Ask questions. Mr. Kim, what if we ask and a teacher doesn't know how to answer it? That's fine, right? Do I get asked questions that I don't know the answer to? Sometimes. I'm okay with that. I'm like, oh, let's look it up, right? What is pH? pH stands for power of hydrogen. That's what it stands for, right? That lowercase p is a mathematic term. The lowercase p comes from math, not from science. Okay? So, it means, it means you know what's cute? Chemistry's cute. pH is cute. It's adorable. It's friggin' adorable, man. All right, so here we go. So it means power of hydrogen, right? But what it really means is this. It's power based on 10. That's what P stands for. P stands for it's the power based on 10. What does that mean? That means that's what the P stands for. What is the power or the exponent if you rewrote this number in terms of 10 to the whatever? That's what P stands for in math. Hey, I'm going to be honest with you. My math class never really explained that to me either. They just assume you know what P is, right? So, pH is negative log of the hydrogen ion concentration. Now, what in the world is this log mean? Log literally means base 10 exponent. Okay? Meaning what? Meaning if you wrote it as base 10 number, what would be the exponent? That's what the log function brings us. You don't have to know this, but like I said, so many kids go through high school where they actually never understand what log is, proper log. Now, are there other logs? Sure, there are base 2. You can have log base 2, right? Whatever. But if you see log with no subscripts, it's number 10 understood. Okay, that's the base 10. If you see no base, it's so, but if you see log subscript 2, that means you're going to rewrite the number so that it'll be 2 raised to whatever exponent will give you that number, and the answer is the exponent, right? So let me try to explain to you. So P means power of 10, base 10, meaning that, right? POH would be log of hydroxide ion concentration, right? If I gave you P orange, that means you take the negative log of orange. Do not overthink this. Do not overthink this. If I say P, Sierra, what does that mean? You take the negative log of Sierra. Mr. Kim, how do you take the negative log of a Sierra? I have no idea, but that's how you would write it. What you would do is take your calculator, press the negative button, press the log button, and then type in Sierra and hit enter. That's how you do it, right? Don't overthink it. If you see the small letter P in front of a number or a term, it just means take the negative log of whatever you see in the term. That's all it means, okay? Everybody okay? So, you ready? Let's see how this works. You can do this without a pH scale, all right? So, let's go with pH scale. pH scale runs from 0 through 14, where 0 is acidic, 7 is neutral, 14 is basic, right? Kids screw this up. They think, oh yeah, higher is acidic. No, lower is acidic. Start with a 7. Good old 7 is neutral. And if you go lower, it's acidic. Higher, it's bitter. Okay? You got to memorize that. Right? So something like a vinegar or lemon would have a pH that is what on a scale? Approximately what? Yes, sir. Less than what? Less than 7, right? pH would be less than 7.0. Right? If a question asks, Timmy, try drinking the solution. Timmy should never do it, right? But drink a solution and it's quite bitter. What do you assume the pH would be? Greater than 7. Easy peasy, right? Now, how does pH work? pH is really looking at how much hydrogen ion is in a solution, okay? Why'd I put it in brackets, parentheses? It's hydrogen ion. Oh, it's because it's a power of hydrogen, right? It's actually power of hydrogen ion, not hydrogen, right? But it's just that if you read that hardcover textbook that I gave you, I think they say power of hydrogen, but it's actually pH is power of hydrogen ion, right? Which is H+. Now, let's look at HCl. We know it's a strong acid. We know that strong acid 100% will dissociate, which means all of HCl will turn into, right? Which means all of HCl will turn into this and that, right? Again, all of this will turn into this and that. But what are we interested in? We are only interested in this. Why? Because, hey, remember, this is a strong acid. Do you guys remember what acid becomes after it gives up its proton? Yes, sir. Yeah, what kind of base? Specific name. What? Conjugate base. And what do we know about conjugates? Conjugate of a strong acid would be what? Yeah, it's a weak conjugate base. That's why we don't really care. Weak base is, it doesn't do anything, okay? But we do care about this guy, though. That is what? That is the active ingredient in all acids. Nice. All right. Guys, what is my perfect world? My perfect world would be I come in one day, try to have class, and Justin cannot say a single word because you're all competing against Justin, right? Jonah, right? Sebastian and Brian for answers, which means that you all study, you all love chemistry. And then I wake up because my dog is licking my face. All right, here we go. So if we have HCl as 0.10 molar, then it's the same as saying that hydrogen ion concentration will also be 0.10 molar, right? And Cl is also 0.10 molar, right? Remember, 100% of it actually turns into those two, right? But we don't really care about the Cl minus, right? Because it's not really an active part. That's why the part in yellow is the most important part, right? And then what do we do? Well, to figure out, right? I ran out of space, so I'm going to go to the next slide. So in order to figure out the pH, what do we need? Hello. In order to figure out the pH, what do we need to do? pH equals negative log of our hydrogen ion concentration, which means it's a negative log of 0.10. Okay, like that. Now, I don't like the next slide, so I'm going to just continue here. So the next slide is the calculator version. This slide is me explaining the math version, right? So, hello. Let's take a look. It's essentially negative log, right? How do you write 0.1? 0.1 is same as 1 times 10 to the minus 1. Okay? That's the same as writing that. In fact, this is the same as writing and when you ask for the, okay, so I'm going to wait till you guys finish writing. And remember, if you take a log, that means the answer is this, right? That means now it's negative 1 or simply 1.0. Okay. So logs can be done without a calculator, right? And they used to teach logs without a calculator in my high school class. Did Mr. Kim pay attention? Heck no. I hated my math classes. But it's only when I, later on in college taking chemistry, I'm like, oh, okay, that makes sense. Okay. So that's the mathematical explanation of why negative log of 0.1 is 1. However, all you need to do is this. All you need to do is literally punch it into the calculator and it'll spit out 1.0 and you're good to go. Okay. So you don't have to go crazy over it. That explanation was just so that on video, if you go back and you really want to know what it is, that's the explanation for it. Got it? But this is perfectly fine, right? Questions, comments, concerns, right? So what is the big take-home lesson here? So you got to understand that. See, I say that in class, in video, but are you doing this at home? What is the big take-home lesson here? But the big take-home lesson here is that for a strong acid, right, concentration of the acid is the same as concentration of our this, okay? Which means that to calculate your pH is the negative log of either one, right? Right? You can get away with that. That's the take-home list. Onward. Sample problem 19.2. Oh, we're in the textbook, kids. Let's do it. What is the pH of solution with hydrogen? Oh, no, Mr. Kim, how do you do this without a calculator? You can. I mean, you can, but you don't want to do that. Right? In AP, I explain it. And even this year, when I explain AP, kids' eyes were all glossed over. They look like eyes at a fish market at H Mart. And I don't mean the live ones, I mean the dead ones, right? So don't worry. What do you do? Calculator time, man. Calculator. Just go calculator, okay? So you just have to know how to set it up, right? That's the equation, right? Oh, by the way, you should memorize this, right? Because it's not given a reference table, right? All right, keep going. So what do? Hey, so easy, right? And then what do? You could only get this wrong if you don't know how to punch this into a calculator. What do you mean? Like if you are borrowing a calculator that you've never used before and you can't figure out those exponents, yeah, then you'll get this wrong. Hence, this is the part of the video where I stop and said, hey, are you annoyed as much as I am? when you try to borrow a calculator and you can't figure out how to do exponents. That's why today's video is sponsored by Get Yourself a Scientific Calculator, right? No? Nobody finds me. Come on, I'm trying to be funny. Let's try. All right, come on, man. You put in the calculator, you get this, right? Except, hey, can you leave the answer like that? No. Done a little bit loosey-goosey, but the way it works is this. The number of okay, you ready? In your SigFig rule book, you don't have to know this, I think, but in sig figs, the number of sig figs, how many sig figs is that 4.2 times 10 to the minus 10? How many sig figs? How many sig figs? How many sig figs is that? 2 is the same as number of decimal places. I know it's a new rule, but if you take logs, sig fig rule for log is if you take a log, the number of decimals in your answer is number of decimal places to equal to the number of sig figs in the original number that you took the log of. That's the sig fig rule for log. That ain't me. That ain't science. That's math, buddy. Right? It's a rule for math. Now, it doesn't matter? The answer is no. Regent's probably not going to ask you, right, to do that, right? But obviously, you don't want to leave it as 9.37675, 6294, 867, right? You don't want to leave a pH like that. So I don't know, 9.4. Will they take 9.4? Yes. But the correct sig figs would be 2 decimal places because it's 2 sig figs. Okay. All right, keep going. Find the pH up. Oh, here we go. What about that one? Oh, so easy, right? I'll give you both. Boom. First one you can do without a calculator. Second one, you need a calculator. You actually could do it without it too, but I'm not gonna sweat it. All right. Anybody know off the top of the head what first one should be? pH should be what? Equal to? Yes. Not 1. Because you're going to take the pH equals negative log of 1 times 10 to the minus 4, right? Log of 1 doesn't come out to anything. It's a 0, so it doesn't matter, right?
1,000.
Nope. Remember, log is asking what that is, right? Yeah. Yes, it's -4, but there's also another negative, which makes it a what? Positive 4, 4.0, right? Now, if you punch it into the calculator, it'll just give you the same value, right? In fact, if you don't believe me, do I have a calculator here? Calc. Aha. Hello. Open. Open. Can I? Hello? What? No, it will not let me open a calculator, guys. Oh, now my computer is hung. Oh, no, there it is. All right, here we go. Here we go. Let's go to scientific, right? How do you do this, right? Depends on calculator on this one. Oh, I don't even know how to write this. God. Oh, here. 10 to the exponent of what? Oh, you don't have to do that. What's 10 to the minus 4? 0.0001. Is that 1 times 10 to the minus 4? Yes. If you take the log of that, guess what? Boom, right? But remember, it's negative log, so it's going to be positive 4. What about this one? Easy. You just have to go 0.0015, press the log button. Where did the log button go? Right here. And boom, you get that, except it's a negative log, so it's going to be what? Negative, it's going to be positive 2.82, right? Decimal places, right? Whereas this is pH is equal to 4, right? It's that easy, right? How do you solve this? Negative log of 0.0015. That brings up a, right, like that. That's what gives you that value, okay? Questions, comments, concerns? Don't forget to hit the like button. All right, let's go. How is pH related to pOH? Very important. In the same solution, it's important, in the same beaker, the pH value plus POH should always equal 14. In Regents, not in AP. In the same solution, pH and POH should always equal 14. All right, I'll be honest. At 25 degrees Celsius. Mr. Kim, what about away from 25 degrees Celsius? That would be AP, sir. So therefore, in regions, it'll always be 25 degrees Celsius. That's why. In bio, in chem, regular bio and regular chem, pH is always at 25 degrees Celsius. Understood, right? Only when you get to AP, you will consider what happens when you go to different deviation of temperatures. This is the reason why, like I said, if you want to come to AP, you got to understand what you're getting yourself into, right? You got to understand pH like backwards and forwards. But if you don't, we're literally going to be doing all the exceptions to all the rules. So if you don't know all the rules, you're going to be confused. Welcome to some of the confused kids in my AP. All right, let's go. Well, we still got plenty of time. Sample problem 19.4. What is the pH solution if POH is that? Oh, no, Mr. Kim, they didn't give us the H+, right? Right? How do we do that? Well, if we can't get pH, can we get POH? Yeah. It's easy. You set it up just like this, right? Then what do you get? Can you do this without a calculator? I wouldn't. I'll put into calculator, get that. How much you want to bet if this is a multiple choice and they give you the hydroxide ion concentration of this, and then they said, what is the pH? How much you want to bet that one of the answer choices is going to be 10.4, right? But it's wrong. 10.40 is not pH, it's POH, right? So how do you get the pH from here? Yeah.
Subtract
From?
both sides from POH, like subtract both sides, and then you get like
Yeah, I know, but how do you do that math, right? What is the actual math? pH plus POH is always equal to what? Hello? 14. So how do you get to pH from POH? Yes. Yeah, 14 minus POH will give you pH, right? Right? So 14 minus POH gives you pH. So that's it. It should be like 3.6, I think. Is it? Yep. 3.6. 3.60 because the POH had 10.40, right? Right. It's that easy. Don't screw up though, right? Like I said, if this is a multiple choice test, right? I bet you answer choice is going to be A is going to be 10.4, B is going to be 3.6, right? Which means the kid, if you start punching through a calculator without writing work down, and as soon as you see on a calculator it's 10.4 and you look down at your answer, you're like, oh, I see the answer, and you just pick that, right? You can't. You got to finish the problem, right? So that's why I said, write your work down. Any questions, comments, concern on this? Easy, right? Let's go. Indicators, right? Color change at different pH values, right? This is an indicator. So indicator requires table M. Table M will tell you what indicators are, okay? Now, this is not easy. Kids screw this up because color changes, right, when they gain or lose protons. Yeah, I know, you don't have to really know that, right? But what's important is this, right? Why would this be useful? Because, hello, how do we use this? For example, phenolphthalein, that's how to name this. Phenolphthalein, used a lot in biology, actually. When it's an acid, what's the pH of an acid? Greater or lower than 7? Lower than 7, right? Right? That means what? Lower than 7, right? What do you think the color is for phenolphthalein? Phenolphthalein. When it's acidic, it's going to be what? It's going to be on this side, right? Lower, which means it's that. That's how you read it. Okay? Okay? So color is colorless. Now, if phenolphthalein is in a base, pH would be what? Greater than 7, right? If it's greater than 7, it'll be here on that side. Right? Oh, I'll change color, right? Again, we have no time. Sure, we have time. We have all the time. No, we don't. All right, here we go. Guys, come on, come on. Here. pH is greater than 7, which means it's going to be on this side, right? Which means it's going to be pink. That's how you use this chart. Okay? So it'll be pink. Can't screw this up, though. They will. Oh, again, what if it's 8.2? They're never going to ask you that. They're never going to ask you regions, a range for an indicator that falls between the two ranges, right? What is it when it's 8.2? It's halfway transitioning from one side to the other side. That's what it's doing. But they'll never ask you for a color for that, right? So when they ask you for pH color change of phenolphthalein, the pH will always be either less than 8 or greater than 9. They'll never give you something in the middle. Got it? But even if they do, you got to figure out which direction they're coming from. We'll talk more about that tomorrow. All right, guys, good job. There's a ton of review you guys need to do. Please make sure you do that.